All right, so we talked a little bit about solving just a regular linear inequality, just like an equation, except our solution is a set of numbers rather than just a single number. So now we're going to solve a compound inequality. Basically, it's just two inequalities in the same problem. All right, all the same stuff as you've already learned, just two of them. All right, so this is one common type of compound inequality that you see right here. This is called an AND inequality. Its fancy word is called a conjunction. All right, but what this means is that all of our solutions have to occur inside both conditions. They have to satisfy both conditions to be true. All right, so our goal is to get y by itself in the middle. So we're going to add 7. And whenever you do something to the middle, you do it to both of the sides as well. So add 7 to all three sections. So that'll be 15 is less than 3y, which is less than or equal to 30. All right, next we need to divide by 3. So again, all three sections. And we get 5 is less than y, which is less than or equal to 10. All right, so this is our solution. Our instructions were to solve, we did that, and graph on a number line. Okay, so we're gonna have to make another one of these number line graphs. All right, remember, I don't really care that you have like a whole bunch of tick marks. I mainly want to see 0. I want to see both numbers in this case, so 5 and 10. And then just make sure you use the correct circle and shade in the correct spot. So 5 is a regular less than, so that's going to get an open circle. 10 has an equal to, so that's going to get a closed circle. All right, and let's just talk about kind of what this says. This says y is greater than 5. So that's saying that I should shade to the right of 5. And then this one's saying y is less than or equal to 10. So I should say left. Less than is left. Okay, and the conjunction, the and problems, the answers only occur when it satisfies both conditions. So in that case, that's where these two overlap each other. So you would shade in the middle. Now you don't have to do this double shading every single time. I just wanted to show you and be explicit about it this first time we're going through it. Okay, when you look at this, I think of y is in the middle, so my shading should be in the middle. All right, the other type of compound inequality is an OR inequality. Fancy term for that is a disjunction. And to be true in this inequality, it has to satisfy either the first condition or the second. It doesn't have to be both. Okay, so either or. That's why or, that's the difference between the words or and and. If any of you are interested in computer programming at all, or and are big in computer programming. You have to know the difference between those. Because sometimes you want things to satisfy all conditions, sometimes you only want them to satisfy a couple of conditions. All right, and that's the difference between using the word and the word or. Okay, so this one's just two completely separate with the word or. There's no way to write it all as a nice, neat, compact thing like the last problem. So it's just going to be two separate inequalities. All right, solve them both for k. So we get k is less than negative 10, or k is greater than or equal to 14/3. All right, we've solved. Now let's draw out. All right, so 0 is about there. Looks like negative 10 will be down here, and 14/3 somewhere up here. All right, negative 10 had a no equal to, so open circle. 14/3 has an equal to, so closed circle. So we're less than negative 10. That's going to go to the left. And we're greater than 14/3. That's going to go to the right. Notice how these two sections do not overlap. But since it's an OR problem, that doesn't matter. We don't need them to overlap. Anything in either one of these sections is going to make this whole statement true. All right, whereas on the AND problem that we just did before, it has to be in both sections to be true. Okay, AND versus OR. All right, so that's pretty much it. There are some abnormal inequalities that I want you to be aware of. Okay, there's 3 types that we're going to talk about for and then there's 3 types that we're going to talk about for or. All right, so I've drawn out some number lines here, so you may want to pause it and kind of give yourself a chance to draw these out so you're ready to go. All right, so this one's x is greater than negative 4, so negative 4 and circle, and here's 0, and x is less than 4. All right, greater than -4, that goes this way, less than 4. Okay, this is a typical AND problem. This is what the normal ones look like. Okay, think of that first problem that we did. Okay, so let's look at a couple of the abnormal. So let's write normal here. All right, this one says x is less than -4 and x is less than +4. So see how the signs are the same? They're both less than. So this one says less than -4, so that's this. This one says less than +4, so that's this. All right, then think about what I just told you on AND a couple slides back. Okay, for AND to be true, you have to be true in both sections. So only where they overlap. So the only place that this whole thing is true is where they overlap, which is from -4 down to -infinity. Okay, so basically this whole x is less than 4 is worthless in this scenario. The entire answer is located within x is less than -4 because that's the only spot where they overlap. So occasionally you'll get problems where when both are going the same direction, one of the part of the answer can kind of be thrown out and you only take the part where they overlap. All right, now remember this is with AND. We're going to talk about OR in a second. It's a little different. All right, and then the other abnormality that you might see, we've got x is less than -4. So that goes to the left for less than. And x is greater than +4. That goes to the right. All right, so this is a graph you would typically see on an OR problem. Okay, but this is an AND problem. All right, so remember the answers happen where the two sets overlap. These don't overlap at all. So if you get this on an AND problem, your answer is no solution. There are 0 places on the entire number line where these two overlap. So no solution. So just be on the lookout. Those abnormalities don't show up often, but you'll see them enough to where you need to know what's going on there. All right, let's take a look at the ORs. All right, so this is going to be a typical OR graph right here. X is less than -4 or x is greater than +4. This is actually the graph we just drew out above that was no solution. But for an OR, it's not no solution because it can be an either or. It doesn't have to overlap. So this is what we would call a normal one. All right, so let's take a look at an abnormal one. This is going to be x is less than -4 or x is less than +4. All right, we've already seen this graph as well. Less than -4 goes this way. Less than +4 goes this way. The difference. All right, this is the main one that mistakes get made on. So on AND, they have to overlap. So it was only from -4 down. But on OR problems, they don't have to overlap. We can take them in either this set from -4 down or from this set. Well, that means that our answer is going to be entirely from 4 all the way down because that's the set that we're going to take. So that pretty much overshadows this -4. So we don't even really need the -4 answer. Our entire answer is located within the x is less than 4. All right, because that's the biggest one, and for OR, you just want to be in either one. So you automatically take the biggest one. Whereas AND, you take the smaller one because that's going to be the only places where they overlap. All right, and last one we get is x is greater than -4. So that's going to go to the right like this. And x is less than +4, and that's going to go to the left like this. All right, now remember with ORs, it's either one. They don't have to overlap. These happen to overlap, but they don't have to. So if I can take either one, that means everything from 4 down to -infinity, that counts as part of my answer. And everything from -4 up to +infinity, that counts as part of my answer. Well, it looks like I've shaded the entire number line at this point, which I have. So that means that if you get, and this is a typical AND graph, okay, but it's actually an OR problem. So if you get a typical AND graph on an OR problem, all real numbers. All right, so again, they don't happen often, but be on the lookout for that abnormal inequalities. They will show up on you.